Hello and welcome to Maths with Jacob. This lesson will focus on modular arithmetic, part 1. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. If you would like to subscribe now, please do so here. Otherwise, you can subscribe at the end. Modular arithmetic. In mathematics, modular arithmetic is a system of arithmetic for integers, where numbers wrap around upon reaching a certain value, the modulus. For example, look at the following clock face. We are all familiar with the concept of a traditional clock face. As the dials swing around, they can only land on one of the numbers on the clock face. No other numbers exist. When they pass 12, they wrap around and start again. This is the principle behind modular arithmetic. Traditionally, modular arithmetic works as follows. In Mod 3, the integers used are 0, 1 and 2. In Mod 4, the integers used are 0, 1, 2 and 3. In Mod 5, the integers used are 0, 1, 2, 3 and 4. And in Mod 6, the integers used are 0, 1, 2, 3, 4, 5. And so on. So, let's look at Mod 5 for example. Whenever you see the 5, you know there are 5 integers. But it does not include the number 5. It's just from 0 to 4. And it's the same for all the others. Simple addition. Let us see how addition works when using modular arithmetic. For example, consider the following addition table in Mod 5 arithmetic. Now remember, in Mod 5 arithmetic we have the numbers from 0 to 4. So here they are from 0 to 4, and here's the addition sign. 0 plus 0 equals 0, 0 plus 1 equals 1, 0 plus 2 equals 2, 0 plus 3 equals 3, 0 plus 4 equals 4, and so on. Now when we come to here, this is interesting. 1 plus 4 equals 0. Just remember that for a moment, and I'll explain why that's the case. Let's go to the next line. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. And 2 plus 3 is 0. So here's the 0 occurring again. 2 plus 4 is 1. Wow, isn't that interesting? So it's not like our normal arithmetic. And you might say, how is that the case? We will explain that in a minute. 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is 0. That is so interesting. 3 plus 3 is 1. 3 plus 4 is 2. And so on as we go through the table. Now, in order to explain how these interesting additions are happening, let's look at two examples. Now, if you look at the table here, we see that 4 plus 2 is 1. So I'm going to look at that example first and see how we get 4 plus 2 equals 1. And that will explain, for example, how all these zeros occur, or how these odd additions occur here that we're not sure about. So let's look carefully. 4 plus 2 equals 1. That's what the table tells us. There it is there, see? In that red box, 4 plus 2 equals 1. We start at 0, like we do on the number line. Always start at 0. Now 4 plus 2 equals 1. Let's go 4 places. 1, 2, 3, 4. So that's our first trip. We've landed on 4, so we're here so far. Now we have to add another 2. 1, 2. And that's why 4 plus 2 equals 1. Because remember, when it goes past 0, They're the only answers you can have, 1, 2, 3 or 4. So it keeps wrapping around because there are no other numbers. And that's why 4 plus 2 equals 1. In a similar fashion, 4 plus 4 equals 3. Let's have a look very quickly. 1, 2, 3, 4. 1, 2, 3, 4. So we've gone around 4 plus 4, and that's why 4 plus 4 equals 3. In Mod 5, for example, the only integers that exist are the ones shown, 0 to 4. So, these are the only answers which are possible. Every multiple of 5 equals 0. The remainders are the answers. For example, 4 plus 3 equals 7 in normal arithmetic. There is no 7 in Mod 5 arithmetic. We start from 0 and count 7 places in a clockwise direction. We land on 2, so that is the answer. So, you saw here that 4 plus 3 was 7. There's the 7 there. 1, 2, 3, 4, 5, 6, 7. And that's why the answer is 2. Because we've landed on 2, there's no such answer as 7. Calculating the answer without a clock. Answer the following in Mod 5 arithmetic. 1 plus 2 plus 3 plus 4 plus 1 plus 2. Now if we had a dial, like we did in the previous slide, we would just go around the circle until we get our answer. But we don't have a dial, so this is how we do it. When you add all these numbers up, in traditional arithmetic it's 13. Now, 13 does not exist in Mod 5 arithmetic, so we do a division. Because it's Mod 5, we divide by 5. 13 divided by 5 is 2. That is, 5 divides into 13 twice. But the remainder is 3. So the answer is always the remainder. Very, very important to remember that. The answer is always the remainder. And we'll see more about that in future videos. Here's a quick quiz to help you, and if you need to check through the video, please do so. What is the meaning of the following? Weekend. I think that's pretty obvious, isn't it? The answers to the quick quiz, check through the video at any time, please. If you enjoyed this video, please subscribe on the next slide, and you will receive a notification as to when the next video is available. Hope to see you next lesson.